All right, today we're going to be talking about inequalities, okay? And we're going to talk about when these rational functions are positive and when they're negative and when they're undefined and when they're actually equal to 0. And here we go. Yes, notes would be good. Okay, to solve f of x greater than 0, which means you're looking for when it's positive, you find the values of x that make the function positive. To solve for f of x less than 0, which means you're looking for when the function is negative, you're finding the values of x that make the whole function negative. Okay, if I look at this function, which I'll look show you algebraically in a second, but here's the graph of this function. You can see that anywhere it's below the x-axis, it's negative. So on this interval, the function falls below the x-axis, which means it's negative. In this section of number line, from -3 to 4, we say that the function is positive because the graph is lying above the x-axis. Same thing over here. So my sign chart that they're talking about would be negative, positive, positive. Okay? Where they are 0 is at -3 and +4. And where it is undefined would be where you would have gaps or if you have vertical asymptotes or anything like that, then the function is undefined there. Okay, so here we go. Here's the same function that was just on the other page. Okay, it says determine the real number values of x that cause the function to be 0, to be positive, and to be negative. So when you're trying to figure out when it's 0, you set it to 0. And you solve. This is a zero product property. So I can say that x plus 3 equals 0, x squared plus 1 equals 0, and x minus 4 squared equals 0. So if I solve the first one, -3, I get x equals -3, and I plot that. That's a 0. -1, x squared equals -1, square root, x equals plus or minus I. Those aren't x-intercepts. Those are two imaginary zeros. And then if I solve this one, x minus 4 squared equals 0, square root, x minus 4 equals 0, add 4, x equals 4. But it's got a multiplicity of 2, which means it's going to be tangent there. It's not going to pass through. But at any rate, to do my answers, for A, what you do is you put them in these little squigglies, and you list your zeros, which is -3 and 4. Okay? B, they want to know where the function is positive at. What you do, okay, you're going to make these kind of imaginary lines here at your zeros. And basically what you're doing is you're going to test every section. We've made 3 sections. We've made from -3 to -infinity. We've made -3 to +4, and we've made +4 to infinity. We have 3 sections of number line. And the graph is either going to fall above the x-axis or below the x-axis in all of those sections. Without graphing it to see, we can do what we call a sign check. And what you do is you pick anything in this section. Don't get crazy. I'm going to pick -5. Okay, so if I find f of -5, that will be -5 plus 3, -5 squared plus 1, -5 minus 4 squared. So if I do that math, I get -2. This is going to be 25 plus 1 is 26. -5 minus 4 is -9, squared is 81. When I multiply all those together, I don't really care what it is, I just care about the sign. This is going to be a negative times a positive, which is going to be negative. I mean, you can get the actual number if you want to. It will be -2 times 26 times 81. Hold on. -2 times 26 times 81, you get -4,212. So at -5, this thing is down at -4,212. Obviously, it's negative. So what we say is this section of number line is negative. Okay? So if I was describing that from negative infinity to get my, oops, I'm not doing positives. Well, this is kind of B and C. Okay, so for C, one of my negatives is going from negative infinity, oops, yeah, going from negative infinity to negative 5, okay, and I'm not going to put anything there for just a second. So now I'm going to test this section in the middle. Anytime I can use 0, I'm using 0. So if I plug in f of 0, I would have 0 plus 3 times 0 squared plus 1 times 0 minus 4 squared. This is going to be 3. This is going to be 1. This is going to be negative 4 squared, which is 16, which is going to be a positive times a positive times a positive is positive. Again, you can figure out what it really is, but I don't care. So in this section, my function is going to be positive. Now if I check something on this side, past 4, let's check 5. So f of 5, I would have 5 plus 3, 5 squared plus 1, 5 minus 4 squared. This is going to be 8 times 26 times 1. Again, I don't know what it is, but it's going to be positive. So this section is positive. Okay, so let me start over and do this in order. Alright, so for B, I want my positives, which is going to say, excuse me, from negative 5 to positive 4. We can't just go from negative 5 to infinity, because right here there's actually a 0. Okay, so we say it's positive from negative 5 to positive 4 union positive 4 to infinity. For C, if we describe the intervals where it's negative, it's only negative on the interval from negative infinity to negative 5. Okay? And then I actually typed it in and adjusted my window and found a graph, and you can see from this point on it's negative, and between the zeros is positive, and on the end it's positive. Okay? Alright, you try one, hit pause, come back when you're ready, and hopefully you got 3. If not, let's look at y. Alright, to get my zeros, you set each factor to 0. So x plus 2 equals 0, x plus 1 equals 0, x minus 1 equals 0, which means x equals negative 2, x equals negative 1, and x equals 1. So I got a 0 at negative 2, at negative 1, and at positive 1, which is going to create these sections of number line. Okay, and I have to pick values in between all of those. So if I start down here, anything past negative 2, I'm going to choose negative 3. So if I plug in f of negative 3, so I'm testing this section here. Okay, I'm going to get negative 3 plus 2, negative 3 plus 1, negative 3 minus 1. This is going to be negative 1, negative 2, negative 4. A negative times a negative is a positive, times that negative is going to be negative. So this section is negative. In between negative 1 and negative 2, we're going to have to pick a decimal. So I'm going to pick f of negative 1.5. So I'd have negative 1.5 plus 2, negative 1.5 plus 1, negative 1.5 minus 1. This is going to be positive, right? I don't really care about the numbers. That's going to be positive. That's going to be negative. That's going to be negative. A positive times a negative is negative, times that negative is going to be positive. So in between here is positive. Now I need to pick something between negative 1 and 1, and I always pick 0 whenever I can. So if I find f of 0, I'm going to have 0 plus 2, 0 plus 1, 0 minus 1. This is going to be positive, this is going to be positive, this is going to be negative. A positive times a positive is positive, times a negative is negative. So in here is going to be negative. And if I pick something on the far side, past 1, let's pick 2. F of 2, I would have 2 plus 2, 2 plus 1, 2 minus 1. This is positive, 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 is going to be positive. Okay? So that's pretty much my sign chart. Now all I have to do is describe it. Your zeros are at negative 2, negative 1, and 1. And you see how they put it? They just put it in these little squigglies and listed them with commas in between. The next thing they asked for is my positive ones. My positive ones are here. I'll get a color that works here. My positive ones are here and here. Well, that would go from negative 2 to negative 1, union 1 to infinity. There's my positives. My negatives, my negatives would be here and here in yellow. Well, this one would go from negative infinity to negative 2, and this would go from negative 1 to 1. Okay? Alright, and if you graph it, you can see here it's negative, here it's positive, here it's negative, and here it's positive. Okay, you see where it's above the x-axis and below the x-axis. Alright, so explain how to make a sign chart for this rational function and explain what the sign chart tells you about this function's graph. I don't think we're there yet because we haven't talked about undefineds. I'll answer this as soon as we hit some undefineds. Okay, so this one says solve this analytically. All right, analytically pretty much means graphically or algebraically. I don't know. Anyway, so, but they're wanting to know when this function is positive. Okay, let me change colors here. They want to know, because greater than 0 is, they want to know when this function is positive. Well, to figure out your sign chart, you've got to come up with your zeros. To come up with my zeros, I have to be able to, before my examples earlier, they had already given me everything in factors. So I just set my factors to 0 and I was good. This is a polynomial, and to get my zeros, I need to get my factors. To get my factors, I need to use my quadratic techniques, which don't work on a third degree function. So we would have to make a list, PQ list, right? And then start trying them until we found my 3 zeros. Or we can cheat, okay? So I found a 0 at, I did it graphically, and I calculated my zeros. So I've got zeros at 4. Okay, and I calculate, oh, I only let you get 1, sorry. Okay, so I found 1, remember, because we only cheat a little bit. So I found 1, I needed to get 1 from the picture so that I can divide and get it down to a second degree. So if I put 4 in the hole, third degree coefficient, second degree coefficient, first degree coefficient, constant. 2 comes out, brings back 8, comes out 1, brings back 4, comes out -6, brings out -24, remainder 0. So this now becomes 2x squared plus 1x minus 6. And if I factor that, 2 times 6 is 12. Factors of 12 that make 1 would be 3 and 4. So I rewrite 3x, 4x. C will tell me my sign. Since C is negative, only the bully gets the positive, and he don't. And everything else comes down. 2x squared at the front, minus 6 at the back. 2 by 2. I can GCF by x, which leaves 2x minus 3. I can GCF by 2, which leaves 2x minus 3. I can GCF by 2x minus 3, which leaves x plus 2. And now I have my other 2 factors that I can set to 0 and solve. So I have 2x minus 3 equals 0, x plus 2 equals 0. This one's easy. X equals -2. This one, add 3, 2x equals 3, divide by 2, x equals 1.5. Okay, so there's my zeros, and we only cheated a little bit. Okay, now, we don't have to answer all of them. They don't want to know when is it 0, when is it positive, when is it negative. They're just asking when it's positive. Unfortunately, you still have to do the sign chart. Well, I can cheat from the graph, but we're not going to do that. Remember, we're going to cheat responsibly. Alright, so I need to pick something in this section. I'm going to pick negative 3. So if I find f of negative 3, I'd have 2 times... I think it's easier to plug it back into the factors. Would you agree that I could rewrite that function as x minus 4 times 2x minus 3 times x plus 2? In other words, I just backed it up to its factors. Okay, and then it's easier to plug stuff into. So if I find f of negative 3, I'd have negative 3 minus 4, 2 times negative 3 minus 3, negative 3 plus 2. This is going to be negative. That's negative 6 minus 3 is negative. Negative 3, that's negative. A negative times a negative is a positive times a negative is a negative. So this section is negative. I'm going to pick something in between. 0's in between, so I'm going for 0 because it's always easy. Alright, so if I do f of 0, I'd have 0 minus 4, 2 times 0 minus 3, 0 plus 2. That's going to be a negative. 0 minus 3 is a negative. That's a positive. A negative times a negative is a positive times a positive is a positive. Pick the next section, something in between there. I'm going to pick 2. Nice and small. So f of 2 would be 2 minus 4. 2 times 2 minus 3. 2 plus 2. This will be negative. 4 minus 3 is positive. 2 plus 4 is positive. A negative times a positive is negative times a positive is negative. So this section is negative. And then I got to pick something beyond. What was that at? 1, 2, 3, 4. So let's pick 5. If I do f of 5, I would have 5 minus 4. 2 times 5 minus 3. 5 plus 2. This will be positive. 10 minus 3 is positive. 5 plus 2 is positive. So this section is positive. So, since all they wanted to know was when my function was greater than 0, meaning positive, it's this section and this section. So, it goes starting at, what was this, negative 2, and this is 1.5, and this is 4. So, it's positive from negative 2 to 1.5, union 4 to infinity. There's where my function is positive. And you can see from the graph, here is positive and here is positive. Everything else is below the x-axis. Yeah? Here's positive and here's positive. Alright. There's a little better graph. Alright, you try this one. Hit pause. Come back when you're ready. You're going to have to factor this one to get the zeros from it. And hopefully you got 1. Alright, this one they want me to find out where the function is negative at. I set my factors to 0 because they've factored. And then this one, x squared minus 3x, it isn't completely factored because it's still got second degree. Should be an easy factor though because a is 1. Factors of 10 that make 3 would be 2 and 5. Since c is negative, only the bully gets the minus, so 2 doesn't, which gives me x equals negative 2, and x equals 5, and x equals 3. So I've got an intercept at negative 2, at positive 3, and at positive 5. So if I break my graph up, into these sections, alright, and I test my points. I have to test something down here, so I'm going to pick negative 3. So again, if I rewrite my function as x minus 3 times x plus 2 times x minus 5. This one, and this one. And I plug in, I'm trying to find f of, what I want to pick, negative 3. So this would be negative 3 minus 3, negative 3 plus 2, negative 3 minus 5. This is going to be negative, negative, negative. A negative times a negative is a positive, times a negative is a negative. So this section is negative. And guys, pretty much, unless you have multiplicities, in other words, you have roots that aren't going to pass through or going to touch and turn, pretty much you can guarantee, again, if there isn't roots with multiplicities, even multiplicities, you can pretty much guarantee once you find one, it alternates, generally. Okay, but I don't ever trust it enough because as soon as I do, I end up getting it wrong. So I'm going to pick something in between. I'm going to pick 0. So I'd have 0 minus 3, 0 plus 2, 0 minus 5. So I'm plugging it into here. That's going to be negative, positive, negative. A negative times a positive is negative, times a negative is a positive. So this section is positive. Pick something between, what is that, 3 and 5? That would be 4. Good color. So f of 4 would be 4 minus 3, 4 plus 2, 4 minus 5. That's going to be positive, positive, negative, which is going to give me a negative. And I'm betting that section's positive, but let's check it out. Pick something beyond 5. Let's do 6. I'm going to have 6 minus 3, 6 plus 2, 6 minus 5. That's going to be positive, 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 which is positive. Told you. Okay, so we just want the sections that are negative. So we're looking at this section and this section. Okay, which goes from, my negatives would go from negative infinity to negative 2, union, start again at 3, and go to 5. Those are the sections that it's negative in. And if you look at the picture, sure enough, it's negative here, and it's negative here. From here to here, and from here to here on the x. Yeah? Alright, so how do you solve inequalities involving polynomials, radicals, absolute value, and rational functions using graphical techniques? Well, the way that we're talking about today is to use a sign chart. Okay? Alright, so now we're going to have some undefined stuff, and then we can answer that last question. My function right now says let r of x equal 2x plus 1 over x plus 3 times x minus 1. Alright, we're going to have some more issues. If you remember, to find your zeros of a rational function, you set your numerator equal to 0 and solve it. Minus 1, 2x equals negative 1, divide by 2, x equals negative 1/2. So you're going to have a 0 at, negative 1/2. About right there. Okay? Now, to get your undefined, that's going to be my only 0. So as far as a goes, my only 0 is negative 1/2. B wants the undefined. Your undefineds are when your denominator equals 0. Right? It's your basically domain values that have to go away. So to get your undefineds, or your vertical asymptotes, or whatever you want to call them, you set your denominator equal to 0 and solve it, which gives me x equals negative 3 and x equals 1. So I'm going to have a vertical asymptote at negative 3 and at, and at positive 1. And those are my undefined. So for B, we say it's undefined at negative 3 and at 1. And then we have to make a sign chart to determine the values of x that make it be positive and negative. So now we're back to testing. But now we have to test in between every 0. Before we just had to test between every 0. Now we have to test between the asymptotes and the 0. So I've got to pick something in this section, this section, this section, and this section. Okay, so if I pick something down here, let's pick -4. So if I find f of -4, I would have 2 times -4 plus 1 over -4 plus 3 times -4 minus 1. On top, 2 times -4 is -8 plus 1 is going to be negative. I don't really care about the number. On bottom, this is going to be a negative, this is going to be a negative times a negative is a positive. And a negative divided by a positive is going to be negative. So this section is going to be negative. I got to pick something between here. I'm going to pick -1 because it's nice and small. F of -1 would be 2 times -1 plus 1 over -1 plus 3, -1 minus 1. 2 times -1 is -2 plus 1 is going to be negative on top. On bottom, this is going to be a positive. This is going to be a negative. A positive times a negative is a negative. A negative divided by a negative is a positive. So this section is going to be positive. The next section, I'm going to pick 0. So f of 0 would be 2 times 0 plus 1 over 0 plus 3, 0 minus 1. That's 0, so the top is positive. On bottom, that's positive, that's negative. Divided by a negative is going to be negative. See how they're alternating? It's because I don't have any double roots. Pick something out here. I'm going to pick 2. So f of 2, I would have 2 times 2 plus 1 over 2 plus 3, 2 minus 1. That's 4 plus 1 is positive, 2 plus 3 is positive, 2 minus 1 is positive. A positive divided by a positive is a positive. There's my sign chart. So, for C, my positives fall in this interval and in this interval. So that's going from, what was that, -3? To -1/2 union 1 to infinity. You describe the yellow lines. For your negatives, you're describing here and here in orange. Okay, so that one will be, for D, we have -3. Wait, I'm doing orange, sorry. So this interval would be -infinity to -3, union, in between there is -1/2 to 1. So there's my zeros, there's my undefined, there's where it's positive, there's where it's negative. And if I look at the actual graph, okay, there's my asymptotes, okay, negative, positive, negative, positive. Okay? Alright, you do this one, hit pause, come back when you're ready. And hopefully you got 3. Alright, so to get my zeros, I set numerator equal to 0, which gives me x equals 4. So there's my 0. To get my undefineds, I set my denominators to 0. So 2x plus 1 equals 0, x minus 7 equals 0, minus 1 divided by 2. So you've got a undefined at -1/2. Oh, sorry, I forgot my 0. 1, 2, 3, 4. That's a 0. Okay, I should do this in different colors. Undefined at -1/2. And at 7. 4, 5, 6, 7. Okay, the blues are undefined and the purple is the 0. So it's undefined at 7 and at -1/2. Okay, so now we do our sign chart. I'm going to pick something down here. I'm going to pick negative 1. If I find f of negative 1, I'd have negative 1 minus 4 over 2 times negative 1 plus 1, negative 1 minus 7. The top, that's going to be negative. That's negative 2 plus 1 is negative. That's negative. That's positive. A negative divided by a positive is negative. And again, I don't see any multiplicity roots. I don't see any double roots. So I'm pretty sure that this thing is just going to alternate signs. But that's not being a good mathematician. We should check. So pick something in this interval. I'm going to pick 0. That's going to be 0 minus 4, which is negative, over 2 times 0 plus 1, which is positive, times 0 minus 7, which is negative. So you have a negative divided by a negative, which is a positive. The positive divided by negative is a negative. So this section is positive. Pick something between 2, that's not 2, 4. No, I write that as 2. Pick something between 4 and 7. I'm going to pick 5. So if I do f of 5, I'm going to have 5 minus 4, which is positive, over 2 times 5 plus 1, which is positive, times 5 minus 7, which is negative. So you got a positive on top. A positive times a negative on bottom is a negative. A positive divided by a negative is a negative. So this section is negative. Pick something beyond 7. I'll pick 8. So f of 8 would be 8 minus 4 over 2 times 8 plus 1 times 8 minus 7. 8 minus 4 is positive. 16 plus 1 is positive. 8 minus 7 is positive. So positive divided by a positive is a positive. Okay, so for C, where they want where it's positive, it's this section and this section, which went from negative 1/2 to 4 and 7 to infinity. Negative 1/2 to 4 and 7 to infinity. And then your negatives is where here and here, which that goes from negative infinity to negative 1/2. And it goes from 4 to 7. Pretty easy? Alright, and if you look at the picture, you can match it. Alright, you try this one. Oh, no, not try this one. This one's together. Okay, so we've got a couple of limitations, okay? We have, first of all, to get our zeros, we set our numerator to 0. So 2x plus 5 equals 0, and the square root of x minus 3 equals 0. Solve this one, negative 5, 2x equals negative 5, divide by 2, divide by 2, x equals negative 2.5. So there's a 0 at 2.5. Negative. This one, square, square, I get x minus 3 equals 0, add 3, I get x equals 3. There's going to be a 0 at 3. Okay, so there's my zeros. To get my undefined says denominator can never equal 0. Square, square, x minus 4 can't equal 0, so x can't equal 4. So at 4, you're going to have an asymptote. Let's make that a different color. Okay. Now, we've also got a restriction, though, because we have a radical in our problem. And that radical in the problem tells me that the square root of x minus 3 must also always remain positive. So if I square, square, x minus 3 has to be greater than or 0. So x has to be greater than or equal to 3. So all of this is out. All of this is undefined now. I don't care about this 0 there. It's not going to be a 0 because it's in the undefined area. So that one's out. My only 0 is going to be at 3. All of this, anything below 3 is undefined because this restricted it. Okay, so now we're going to do a sign chart. I got to pick something between 3 and 4. Let's pick 3.5. If I find f of 3.5, I'm going to have 2 times 3.5 plus 5 times the square root, what did I pick? 3.5 minus 3, right? All over 3.5 minus 4 squared. Okay, that's going to be 7 something plus 5 that's going to be positive. 3.5 minus 3 is positive, and the square root of a positive is going to be positive. On bottom, that's a negative, but squared is going to be positive. So you have a positive divided by a positive, which is going to be positive. So in between here is going to be positive. Pick something on the other side. Let's pick 5. So f of 5, I'd have 2 times 5 plus 5 times the square root of 5 minus 3 over 5 minus 4 squared. That's 10 plus 5 is 15. That's a positive. 5 minus 3 is positive. The square root of a positive is a positive. 5 minus 4 is 1. Squared is positive. So that's also going to be positive. Okay. So, my zeros for A is at 3. For B, my undefined is everything less than or equal to 3 is undefined. Well, let's do it in interval. It's undefined from here to here. So it's undefined from negative infinity to, what was that, 3? Right? And then C, where is it positive? We've got to skip that asymptote. It starts being positive at 3 to 4, union 4 to infinity. Yes? And then D, where is it negative? It's not. Never. And if I look at the graph, do you see how it's never negative? It never falls below. This thing actually comes up and does this turnaround thing and comes back down. Okay, but you can see it's never negative. But there's an asymptote here at 4. This actually doesn't connect. It just goes up there, then it comes back down this way. Okay? Alright, so you try this one. Hit pause. Come back when you're ready. And hopefully you got, come on, number 2. Alright, so if I look at this, they want my zeros. Well, my zeros are going to be when my numerator equals 0. So, both of those. Minus 5 divided by 2, negative 5 halves, which is about negative 2.5. That's going to be a 0, maybe, if it doesn't get eliminated. Square, square, x minus 1 equals 0, add 1, x equals 1. I got another 0 at 1. Okay, then to get my undefineds, I set my denominator equal to 0. X minus 3 squared cannot equal 0. Square, square, x minus 3 can equal 0, so x cannot equal 3. I'm going to have an asymptote at 3. Yeah? Okay, so one at negative, or at negative 2.5, one at 1, and one at 3. Okay? Alright, so now we've got a restriction because of that radical. That radical must always stay positive. So the square root of x minus 1 has to stay greater than or equal to 0. Square, square, x minus 1 greater than or equal to 0. X has to stay greater than or equal to 1. So anything that is below 1, all of this is undefined. Because this says x has to stay greater than or equal to 1. So everything below 1 is undefined. And then I have to test. If I pick something between 1 and 3, I'm going to pick 2. F of 2, I would have 2 times 2 plus 5, square root of 2 minus 1 over 2 minus 3 squared. That's 4 plus 5 is 9. That's a positive. 2 minus 1 is 1. Square root of 1 is positive. That's negative 1 squared, but that's a positive. And a positive divided by a positive is going to be positive. So this section right here is positive. And guess what? Because of that square root, the other side is going to be 2. But let's test it. Let's pick 4. So if I got f of 4, I'd have 2 times 4 plus 5 times the square root of 4 minus 1 over 2, what did I pick? 4 minus 3 squared. 9 plus 5 is positive. 4 minus 1 is positive. The square root of a positive is a positive. 4 minus 3 is 1. The square root is a positive. So again, this side is positive as well. So if I describe my zeros, my only zero, this one I had to throw out because he was in the undefined section. So my only zero is 1. It is, for B, my undefined function is at 3. There's going to be my asymptote. It's positive. Oh, my bad. Undefined. Sorry, there's 2 undefined. It is undefined at 3. And it's also undefined from, I think I missed one on the last problem, guys. I'm sorry. It's also undefined from negative infinity to positive 1. This is all undefined, and this is undefined. Okay? For C, where is it positive? Well, from 1 to 3, union 3 to infinity, and where it's negative is no solution. Let me back up a sec. I think I did miss. I did. I'm sorry. Your function is undefined from here to here, yes, but it's also undefined right here. So it's negative infinity to 3 union. It's also undefined at 4. 1, 2, 3. Yeah, it was also undefined at 4. Yeah? Oh, and I needed a union. Yeah, I did the union. Okay? Alright. Okay, so now when we have to solve an inequality, we want to clear the fractions, okay? So to get rid of this division by x, I need to multiply by x. Every term on both sides, okay? Then to kill an x squared, I need an x squared, but I already have 1x, so I just need a total of x squared. I don't need x cubed. 2 is big enough to kill 1. Alright, so if it doesn't die, we multiply. So this is going to give me 3x squared. This x will cancel one of those, which gives me positive 23x. This kills that, which gives me negative 8, and less than or equal to multiply, and that's still 0. So I'm trying to solve this function and find out where it's negative at. So again, I need to get factors so that I can get zeros. So 3 times 8 is 24. Factors of 24 that make 23 would be 1 and 24. So I'm going to rewrite 23x as 1x and 24x. C is negative, which means only the bully gets the middle. Bring down the rest. So I have 3x squared on the front minus 8 on the back, 2 by 2. On this side, I can GCF an x out, which would leave 3x minus 1. Here, I can factor out an 8, which would leave 3x minus 1. Then I can factor out a 3x minus 1, which leaves x plus 8. Set those to 0. Add 1, I get 3x equals 1, divide by 3, divide by 3, x equals 1/3. So we're going to have a 0 at 1/3. Minus 8, we're going to have a 0 at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's going to be my zeros. Okay, in my original function, you had x on the bottom. So in the original function, we have to say that x can never be 0. So I have an undefined at 0. Well, that's going to stink. Getting something in between there to test. Alright, and they want to know where this thing is negative at. So I have to check signs. If I pick something down here, like -9, and I plug it in, and I'm going to plug it in here because it's easier to plug it into factors. If I find f of -9, I would have 3 times -9 minus 1 times -9 plus 8. That's negative. That's negative. That's positive. So this section is going to be positive. Right there. Pick something in between. I'm going to pick -1. So if I find f of -1, I'm going to have 3 times -1 times -1 plus 8. Wait. 3 times -1 minus 1 times -1 plus 8. That's negative. That's positive. So that's negative. So this section is negative. In between is going to be positive. I should check, but it pretty much is going to alternate. And I don't want to pick something between 0 and 1/3. So I'm going to pick something over here. Let's pick 2. F of 2. I would have 3 times 2 minus 1. 2 plus 8. This is 6 minus 1 is positive. This is positive. Which is positive. Why is it?
You could have chosen 1/4. That's easy.
Wait, why did I get another positive? Oh, because of the square root. I don't know. Why did I get another positive? Pick 1/4?
Yeah, that's in between 0 and 1/4.
Alright, let's pick 1/4. Because Miss French is crazy. 3 times 1/4 minus 1. 1/4 plus 8. That's 3/4. Take away 1 is going to be negative. That's positive. Oh, so it's negative. See what I get for assuming? Then why are there 2 negatives? Shouldn't it alternate? Oh, let's see the picture. What does that mean? This is negative. That's not positive. Why is it? It's not positive over there. Okay, sorry, I had to pause there and consult with a colleague of mine. Okay, all right, so we've got this negative thing, and it was when I was looking at the graph, because I'm not used to 2 negatives happening in a row. Usually it alternates. So what's happening is at 8 here, this thing, and I did a different window and actually looked. This thing actually does cross through past there, so it is positive over here. It is negative in this section. Okay, in this itty bitty section, it's negative until it gets to like that 1/3, and right past it, it crosses over. You can't it looks like it's straight up and down, but it's not. It really passes over there at up until 1/3. It's negative at 1/3. Well, somewhere around in there, it turns positive, and then the rest of the graph is positive, like we said. Now they just want the negative parts, which will be here and here. So that would be the negative goes from -9 to 0, union 0 to 1/3. There's where it's negative. Okay? Alright, you try this one. Hit pause. Come back when you're ready. And your answer should be that. Again, you're finding where it's negative. So if I multiply everything by x squared, I get 3x squared plus 14x minus 5 less than or equal to 0. 3 times 5 is 15. Factors of 15 would be 1x and 15x. C is negative, so bully gets the middle. First and last come down. 2 by 2. Factor out an x. 3x minus 1. Factor out of 5. 3x minus 1. Factor out of 3x minus 1. X plus 5, which gives me zeros at 1/3 and negative 5. So 1/3, again, would be about right there. Negative 5, 1, 2, 3, 4, 5 would be about right here. Okay, so there's my zeros. My undefined is when the denominators equal 0, so x cannot equal 0, so I have an asymptote there. That's undefined. Okay, yellow is undefined. Alright, so if I test my points, if I test something down here, I'm going to test -1. And again, I'm going to plug it in here. So if I find f of -1, I would have 3 times -1 minus 1 times -1 plus 5. 3 times -1 is -3. That's a negative. That's a positive. That's going to be negative. So this section is negative. Pick something between 0 and 1/3. I'm going to pick a fourth again. So I would have f of 1/4 equals 3 times 1/4 minus 1 and 1/4 plus 5. That's positive, and it's 3/4, which is not bigger than 1, so that's going to be negative, and that's going to be positive, which is going to be negative. So this section is -2. And then I'm betting that last section is going to be positive. If I pick something past it like 1, I would have 3 times 1 minus 1 and 1 plus 5. That's 3 minus 1 is positive. Positive. This section is positive. So it's negative, okay, from negative, and if I pick something over here, it'd be positive, which I should have done. So it's negative from -5 to 0, and from 0 to 1/3. Okay? And if you look at the picture, there you go. Alright, so how do you solve inequalities involving polynomials, radicals, absolute value, and rational functions using algebraic techniques? Well, you want to factor, however, either using a PQ list or algebra, whatever. Factor, get zeros, make sign chart, and find where the graph is what you're looking for. Find where it's either positive, negative, 0, undefined. You can get anything you want from the graph. Alright, so we are at homework, which means we are done. Happy homeworking, and I will see you next time.